So I'd like to get started. My name is David Wright. I'm out of Eagan, Minnesota, and I've been running this class since the product first came out. You should be able to see a preface slide that I'm going to now go through. Basically, let's go for each buddy's benefit around it. Again, I'm Dave Wright out of Eagan, about 30 years of Unix, former Cray, primarily dealing with performance evaluation system tuning, and ICE Tempo is a product I've been doing quite a bit too. Connie, you want to explain to everyone your background?
Connie Griffiths. I'm up in British Columbia, Canada. I've been at SGI for 21 years and Intergraph before that for 5. I'm an escalation manager in field tech support. Actually don't have to know anything apparently to do the job, but what I expect to get out of the class is an understanding of tempo and the clusters and ICE to some degree, simply to help me manage escalations better.
Megan, you want to just let everyone know your background?
Certainly. I've spent over 20 years working on NASA contracts, primarily working on Linux hardware, usually in Beowulf cluster setup. I am very new to SGI. I was hired by them, started work about 10 days ago, and I'm here to learn how to basically manage an SGI ICE 8200.
And Kevin?
My name is Kevin Kennedy. I'm in New Mexico. I support an Altix ICE cluster that is housed at Intel in Albuquerque. I have about 20 years of experience, most of that being with the federal government. What do I want to get out of this class? Basically, I have a lot of loose ends I just like to button up with PBS and other things that are going to be explained in this course.
You said PBS?
Yes.
We're not going to spend any time really on PBS. We are going to integrate it into our system install, but we don't have time to actually go through the chapter, but we can work something out.
Okay, I just have some questions I need answered.
And for everyone's benefit, I primarily do the morning get through the slides for the day, but you really learn from doing. So I want to get through these slides as quick as possible and get you to lab. And when you're on your George cluster, I would be supporting you through email, or if it requires a phone call, you would call me. Preferably dealing with email, but I'm here as needed. So if I can go on, basically I need you to know how to use a standard bash type of shell. Common denominator editor being VI. You don't always have Emacs. BusyBox, for example, doesn't have any fancy editors. You got to be able to survive with VI. We're also probably going to have to deal with parted. Don't really have to deal with makefs or mount much. And again, I don't know how much background people have in Pixie Network boot issues. This class does kind of hope that you've got some basic background on DHCP, TFTP boot, DNS being used throughout the cluster, network time protocol. We are going to configure NIS in the cluster, NFS, network address translation, be familiar with SSH, and a new update capability, SMT, subscription management. That's really a minor thing, but we do want to update our cluster during the week. Now, if there's any areas that you're weak on, don't be afraid to ask short questions during the presentation, but sometimes it's probably better to wait until you actually hit the problem in the lab. But again, don't be afraid to ask questions, email me, wherever you get stuck. I don't have faces to look at to say he's still puzzling over that, so you've got to get back to me. If you get frustrated or stuck on a lab, I wouldn't say overreact and send me email right away. Think about it for a few minutes, but don't let it go more than 15, 20 minutes before you ask for help. If I help too quickly, then it doesn't sink in. Okay, so page P5, they're basically going to describe the ICE hardware this morning. I have to admit the materials are not up to this last week's release of the newer version, but we can kind of talk about the differences. Hardware is changing quite a bit, but the basic infrastructure is the same. Want to be able to power the system up and down? You've already gotten to the IPMI tool serial console, and IPMI tool is also how you're going to connect to the admin node to do things. And then from the admin node, you can use C-Power to power the system up and down. Fourth step, install Temple on the admin node. George 1 and George 2 have already been added, are basically done with the CD boot and ready to be used. Now here's my problem. For some reason, because I believe of the netmask or something, IPMI tool is giving us timeout problems within this training subnet. Once you're inside the cluster, IPMI tool seems to work fine. So some people have trouble getting the serial, it times out and they don't get the serial console quick enough to do a network PXE boot. I'm going to try to demonstrate this on George 3. So rather than get frustrated on it not picking up your serial console connection in time, last night I basically had 2 of the nodes PXE booted and installed. We're going to basically, when I finish up with lab, you're going to do the first boot. You're going to do a reboot on these nodes and then come up with your normal YAS screens where you're putting in host name, IP addresses, stuff like that. So you'll be finishing the admin node basically right after the reboot. Normally what you've done is stuck in this boot CD and it's booted on it. It takes about 20 minutes to do a make FS and an install, and then it drops to a BusyBox prompt. That's where you are. You're going to do a reboot and then go through your YAS stuff. After the Temple admin node is installed, you're then going to image the lead node. The lead node is the NFS server to all the compute nodes, and it's the management server for the compute nodes. After the lead node, you're going to image the service node. We have one service node for you. This is what you log into. Some people might call it the head node, login node, service node. Also, there are compute nodes that will get automatically imaged when you image the lead node, but we want to make sure that they do get imaged correctly. Also today, you're going to talk about the console command. Console, once the cluster is up, is how you get the serial console of the nodes within the cluster. So use IPMI tool to connect to the head admin node through the BMC, and then console once you're in the cluster to connect to anything else. That's basically the day's tasks. Tomorrow you're going to manage and monitor the network, check integrity of the network with IVT, inventory verification tool. Page P6. This is going to be the painful part for you, customizing the cluster. I wanted a user-ready cluster. The labs are going to have you do some things, but I've already written some scripts to set up some things for you. NIS is where people usually get stuck, and it won't be easy for me to help you with NIS problems without seeing your console and stuff. So expect a little bit of slowdown when we get to the customized section. But by the end of the week, I want a cluster that is ready for users that has MPI and OpenMP applications running on it. Also, during the week, and I'm going to want you to tell me when your cluster is ready for me. I'm going to have you create an account for me, and I'm going to log in and start telling you what's wrong with your cluster. You're going to do things like install Intel compilers, get Intel MPI going, SGI NPT. It's not required in this class, but MBAPICH, MBAPICH2, OpenMPI are some other MPI packets that we can customize and get into the images. You're also going to use some cluster commands, what are called the C3 commands, or distributed shells, PDSH. So I'm hoping Wednesday sometime in the afternoon you've given me email and said your cluster is ready for users to attack it. At that point, I'm going to be running some applications to see how well it tests. There's not time in this class, but in the advanced class, we try to get you to run the Intel cluster checker to make sure that it passes a cluster test. After the system's got usability and everything, you're going to use Ganglia to monitor the cluster, and we're also going to talk about Performance Copilot within the cluster and PMICE. From there, being able to go through the process sometimes on Thursday, I'm going to have a drop a node, hang a node, things like that, and then you'd have to identify what node I hit, take it out of the active use and make it unactive, and then add a failed node back in. I do want you to have problems. I don't want the labs to work perfectly. I want you to think about what you're doing. I used to actually plant some bugs in there, but some people got frustrated by that. I intend to actually have PBS or torque. You get to choose when you're customizing which one you want and put them in and be able to use them, but I'm not planning on any lecture on them, mostly for time reasons. And also not listed here, being able to update your cluster. I'd like to do that during the week, but that can be painful, and it may take overnight to actually download updates and stuff from Novell. Page P7, there we are. I would like to be able to get Perf Suite running, but that's optional. So Perf Suite and PS Run is how I profile applications to find out what library routines they're using. But that's an optional type of thing, depending upon if you know what it is and need to know it. Again, updating the cluster, sometime Wednesday or Thursday, be able to register the cluster, download the updates, and then apply them, and make sure your cluster still works afterwards. We do not have time to do upgrades in this class. That's what the second week is for. And you don't do upgrades very often anyway, so it was just too time consuming. We cover it in the second week. If you really wanted to try it, we can follow on. You know, these machines are available off hours, available next week, that sort of thing, and can be reserved. So if you wanted to practice an upgrade, we can arrange that. Lastly, on Friday, basically troubleshooting, getting ESP configured, and being able to get a traceback. I want to hang a node and get a traceback and get a dump on the system. And then, depending upon time, I will at least try to demo using Crash to analyze a dump. But there may not, on the last day, be time for you to play around with tracebacks and stuff. So that's basically the big steps. Page P8. At the end of the day, I'd like a base tempo cluster installed. So the lead nodes, compute nodes, and service nodes are all discovered and imaged and booted. Tomorrow morning, get InfiniBand working. And then by noon Wednesday, have a cluster ready for users. Now that, frankly, usually ends up in the middle of the afternoon. And again, I intend to just morning, get through the slides and the lecture as quick as possible and get you to doing. So sometime Thursday morning, users are ready, applications are running, MPI is working, MPT is working, then we can start monitoring the system using Ganglia and PCP. And then end of Thursday, applying updates, being able to use sync repo updates and cimage commands to upgrade your cluster. And then lastly, Friday morning, just being able to deal with failed nodes, hung nodes, being able to get tracebacks and dumps, that sort of thing. Again, Friday afternoon, if there's any more, there's lab time available Friday, Saturday, Sunday, should you want to use that time. And don't be afraid to send me email at any time on anything that's in the materials or anything that I talk about in the class. So, what you should have gotten from the URL, first of all, is the slides that are matching what I'm presenting here called IceCast-SM. That's the training manual that I've put together. We also have out on DMZ-server the Tempo ISO. We're not doing DVD because I'm not there to shuffle DVDs. So we're doing a Pixie boot off the Tempo ISO. DMZ server is configured to do a Pixie boot of the admin nodes. This manual is oriented towards Tempo 1.10, which does not support SLES 10 SP2 anymore. So everything should be written for SLES 10 SP3. If you wanted to do SLES 11, I can help you with that. That's something we usually do in the second week, where we actually install SLES 10, SLES 11, and Red Hat on 3 different slots of the admin node. But again, give me any feedback if there's something specific if you want to do SLES 11. We're not supporting SLES 11 SP1 yet. I have not seen that in the Tempo product set. Also, we're using ProPack 6 SP6. So the Tempo ISO, the SLES ISO, and the ProPack ISOs are all in DMZ-server. There's a /install and a /ISO type of directory there. Also on the training lab system DMZ server in archive IceCast lab files are Intel compilers, Intel MPI, and a license to run them. Now the manual may be still written for the Intel 10 compilers. I myself am using the Intel 11 compilers these days, and when you get to that step, just make a note which compiler set you want to work with. Ultraviolet, for example, is a Intel 11 compiler requirement. Also some program examples, an NPI ping pong test, and a graphical tool to do fractal generation, a Mandelbrot generator. And when you get into customizing, there are extra shareware RPMs, such as MBAPICH, MBAPICH2, PBS Pro, things like that. These will also be found out in IceCast lab files. If you can't find anything that you need in the lab, email me. But everything that's needed is in /ISO or /install on the DMZ-server. And again, when you're doing labs, don't just follow the labs. Think about what you're doing. Don't just do it step by step. Page P10, there is a system admin guide that's available out there. Again, my materials are still written for SLES 10, SP3, and Tempo 1.10. We do have a cluster right now that's got 2.0 installed on it. The other instructor, Jim Martin, did that last week. So the Tempo admin guide might be newer, but backport's fine. There's also a user guide, and then some of the products that are contained within Tempo, System Imager. Tempo is based upon Oscar, C3, the Open Fabric Enterprise Distribution for IB, Software and Daemons, and the Ganglia website. Any questions at this point? Anybody still there?
Yeah, I sent the chat. What is your email address? You said we could email you if we...
Yep. DAW@sgi.com. I'm putting it in the chat.
Thank you.
And by the way, I'm not watching chat, so it's real small text. Everybody see that?
Yes, thank you.
And I do monitor email 24 hours a day, it seems like. So, if you wanted to spend some time early tomorrow or something like that playing with labs, we're all in different time zones, so I'm in the central time zone. Anything else? So I'd like to go for a little bit more before we take a break, since it took us a little bit to get connected. And I'm skimming through the slides quickly with the skills and the tasks being learned by doing in the lab. So don't be afraid to slow me down with questions, but I just want to walk through the slides. So we're in Module 1, Overview. Key thing here that you need to understand as you're installing is the difference between the lead, the service compute, and I should have included the admin node there. Talk about a hardware component overview, describe the components of a service or lead, and then the components of a compute. Also then understanding the different networks we have. There's administrative network, there's user networks, there's IB networks, understanding the IP addresses that they're using, and the naming conventions that they use. So ICE stands for Integrated Compute Environment. It is a blade-based high-density cluster. You get basically 64 nodes in a rack, but the 512 processor count has now gone up. There is an edge test related to this that's not current to what was released this week or in the past week. You can go ahead and take a look at the SGI website. But basically now, instead of a 4-core type of system, we have 6 cores on a socket, and I think it was 1768 with hyperthreads, 1768 cores that we can have in a rack. Okay, so we'll talk a little bit about that. But there's now 6 cores on potentially 6 cores on a socket, plus virtual cores or hyperthreads. A hyperthread basically is saying the chip, the core, has 2 states on it. It has 2 sets of program counters, 2 sets of registers. They still share functional units. They still share the caches. But basically, they have 2 program counters, 2 sets of registers, or 2 states. And when you context switch between 2 chips, you don't have to go to memory when you're context switching between 2 processes or threads. So if you take 12 times 64, I think that should get you up higher. 12 CPUs to a blade, no, let's see, 24 CPUs to a blade, 12 CPUs to a socket, counting the virtual. So you basically have 6 cores on a chip now, or 12 virtual CPUs, 12 virtual cores. Okay, come back to that. So each compute blade has a 2-processor socket that supports dual or quad, and again, we're now supporting 6-core processors. And with hyperthreads on, that's 12 virtual cores on a socket. And then 8 buffered DIMM slots. It's a 24-inch wide chassis. Again, we have 16 compute blades that fit into this IRU, which is an SGI rack component to plug our blades into. So these 16 blades have 2 sockets on each blade, and again, 12 virtual CPUs per socket, 24 per blade. Now this motherboard, this compute node, and this cluster is InfiniBand native. All user traffic, SSH, NFS, stuff like that is going over InfiniBand, not Ethernet. There is Ethernet there, but it's used for administrative purposes like DNS, NIS. It's also used for imaging and stuff. So each IRU has in the back panel and native on the motherboard InfiniBand. There's no PCI bus or PCI card. It's native off the I/O chipset. And again, this is what's changed in the past couple of weeks, but it's now a quad data rate instead of a double data rate. It's now QDR technology. Now each IRU has in the back panel a dual plane star topology. There's 2 separate fabrics that are completely independent of each other put together into a star. I'm not sure about any, there might be newer topologies and newer IRUs, but I'm not aware or don't know the information there. I know on ultraviolet we're doing a torus 2D topology within the back panel, and then fat tree between the IRUs. This ICE system, first of all, has an admin controller. Only root can get to it. A lot of sites you can only walk up to it. It's not even on a public network. It's one per system, and it enables the cluster management and imaging, basic administration of the cluster, powering up, powering it down, imaging, updates, things like that. The system admin controller is the thing we're going to install first. And two of them basically already halfway through the install. The next thing that you're going to have to image once you've got your admin node built is the rack lead controller. This is one per rack. So every rack has a rack lead controller. And it communicates with the compute nodes and provides IV management. Control the routing tables for the InfiniBand switching technology. So there's one RLC per rack. And they are looking at redundancy and stuff, but I don't have any of that sort of information in this manual right now. Third type of node we have are the service nodes, one or more per system. We're given one, and it's our login node. It's what users will log in and submit work to. There are sites that have a separate node to run PBS. There might be a separate node for network traffic, for a network gateway, so it does not go through the service node. And you might have service nodes for NAS, for network storage. So we got an admin, a rack, a service, and a compute. And a node or a blade is the same thing as a host name. They are each independent systems. Page 1-4. So the 8200 does not have a head node anymore. It's what they call a hierarchy. A lot of us still will name drop head node, but we have different types of head nodes now, different functionality. And again, the ICE system is what they're calling thin nodes because there's not a whole lot of CPUs there. But the system scales in 2 dimensions, number of compute nodes you need for your computational requirements, and then the number of service nodes you need to support the users and the workload that you're going to run. So they call it a 4-tier hierarchical concept. First of all, we have the admin controller. There is one per system. You do have the ability of, if it fails, doing a cold spare swap. It would mean service interruption. And the spare that you have has to be factory ordered, so it has the same serial number as the system admin controller you currently had. Then we have the rack lead controller, one per rack. And in the IRU is something called the CMC or Chassis Management Controller. We also now have these in the ultraviolet. For Altex people, the CMC is almost like an L2. And it's putting it's one per IRU and putting all the BMCs and all the networks together. So the CMC is really also an Ethernet switch. And the fourth component on these systems, we have what's called a BMC, Baseboard Management Controller. Every node has one. There may be IA64 storage nodes that don't. But in general, all the x86 systems have a BMC. That's equivalent to an Altex L1. That's a maintenance port into the host, into that node. So again, the compute node has a BMC, the system admin controller, the rack lead controller, the service nodes, and the storage node if it's x86. So the ICE 8200 was the original implementation. The one they released this last week is called the 8400. It's instead of double data rate, gone to quad data rate, and also up the core counts on the socket. So we went from basically 4 to 12 when you count the virtual hyper-threaded CPUs. There's an ICE 8200 that is the high-end second generation with a better interconnect topology. Original 8200, the switches that are these InfiniBand switches connections would not enable all ports to be used at the same time, but now we have what's called non-blocking. In other words, we've got an equal number of input and outputs to the switch. And there's the XE has two non-blocking fabrics. The lower entry, the 8200LX, again designed for lower cost, is supporting a two-switch configuration that creates a non-blocking, but we only have one fabric. An IB0, we do not have the IB1 there. And again, I don't have any slides here, but the 8400 was announced in the past week. And it's on www.sgi.com. Any questions?
No?
How about you, Kevin, Connie?
No, I'm good.
I
Hank.
can't.
Okay. So this hierarchy concept, we have a system admin controller. If you can't get to that, you're in trouble. I have already directed all three of you to get to your admin node. So there is a, for example, George1-admin.sgi.com. George1-admin is the SSH port to get into it if it's already got an OS. And then George1-BMC is the serial console to do boots and shutdowns. From that admin node, there is an Ethernet interface to all the service and rack lead controllers that are in the cluster. This is an Ethernet interface. Users don't use this, but NIS, DNS, NTP, things like that will use VLAN head. So off the VLAN head then, we have a connection to the rack lead controllers. Instead of a tree here, it really should just be a ring. They're all connected to the same Ethernet. The rack lead controller then has the compute nodes on it. So there's 64 compute blades or 64 compute nodes in each rack. These compute nodes cannot get to VLAN head. They cannot get to the admin node. There is no path or route to get from a compute node to the admin node. Or vice versa, the admin node cannot get to the compute node directly. It has to go through the lead node. This allows scalability. You're going to see later the IP addresses in each rack are redundant with the IP addresses are reused in each rack. And this allows us some scalability, and each rack's Ethernet interfaces are just for that rack. So there's no traffic between racks in this DNS, NIS, network services type of interface. That network that the compute blades are on is called VLAN GBE. So again, VLAN head is for the admin node to talk to everything that is going to image and manage. And then VLAN GBE is the network all the compute nodes are on to talk to the rack lead controller. And VLAN GBE is where NFS route traffic is going, swap traffic, things like that. We also have a storage node. Now this one's marked in A450, but we do have other types of storage nodes now. And then also our service nodes. So 1-7, the system admin controller or admin node, one per cluster. You have a cold spare. It has to have the same serial number as the active admin controller. So it was ordered from the factory that way. If the system goes down, there is a procedure in the admin guide to basically save your disks, break your mirror, move them to the new system. And then reboot, and then make sure that those moved disks are seen by the new system. Now we're talking Temple 1.10. Prior releases supported /10 SP2, but Temple 1.10 and ProPack 6 SP6 only supported /10 SP3, /11, and RHEL 5.4. I don't know why I'm not listing SLUS 11 here. It is supported. The admin controller is an external LAN interface, but some sites for security reasons do not connect it to a public LAN. Then you actually have to walk up to the console to do anything. Network connections. The admin node has access to the RHE controllers, so there's that VLAN head for GigE, but it cannot get to the CMC and compute nodes because those are different networks. What happens on the admin node is the SGI temple commands will SSH to the lead node and run the commands via SSH to make it transparent. Admin controller has no InfiniBand. It cannot get into the InfiniBand network. Partially, expense, and we want all the InfiniBand ports to be used for users. Again, the admin controller is used by administrators to provision, which is a fancy word to say image, and it's basically a PXE boot network installation server, and a repository control and an install tree as well. You also use the admin node to manage things, to be able to power things up and down, to monitor the cluster. And I have to be a little bit careful since we now have the SGI Management software, the SMC, the Management Console. That's different. That's ISLE. This is not. The rack lead controller, you get one per rack. SLUS 10 SP3 or RHEL 5.4, again, SLUS 11. ProPack 6 SP6. Now the rack lead controller is providing a system boot image and booting the compute nodes. The compute nodes do not have disks. Now there is an option coming out where they will be able to put disks on the compute node, but that would be for scratch I/O, not for booting the system. So /ITSI/var and /root are all on the rack lead controller and NFS mounted to the compute nodes. We also have a swap file there for compute nodes. One thing you don't want to do is get swapping 64 nodes and have 64 swap files filling up. Also, you do have the ability, instead of using the NFS server, to have the compute node have a tempfs root. But to me, that is wasteful of memory. You're going to waste 4 gigabytes of memory per node. So there may be 64 nodes in your rack. That's 256 gig of wasted memory. You will, in lab, do a tempfs type of root. I normally do not advise it. Let the cache hold what you need. Really, you only need maybe 200 meg to hold the active stuff that a root has. So there's a lot of wasted space there. You will go in and find these images a little bit later. The rack lead controller is also running the management software for the InfiniBand fabric, controls routing tables. Rack lead controller, again, has GigE to the admin node on VLAN head, and then another GigE to the compute nodes and to the back panel of the IRU called VLAN GBE. There's also another subnet for the chassis management consoles. The CMCs are little busy box systems that manage a GigE switch, manages the fabric, the InfiniBand switches, and manages the compute nodes, BMCs, and power. We'll come back to the CMC later. CMCs do have a name such as a C in them, I0C, I1, but say I'm in IRU0, and each IRU only has one CMC at this point. So it's I0C, or for example, I3C would say it's the CMC for the third IRU. The rack lead controller does have InfiniBand to the cluster. It's provisioned and installed by the system admin controller, and basically via SSH is moving data between the compute nodes, the IRUs, and the admin controller. We'll note there SAC uses SSH to R1 lead, for example, to get the compute nodes info. Okay, we have a compute node up to 64 per rack, 16 to an IRU. SLUS 10, SP3, SLUS 11, and RHEL 5.4, and ProPack 6, SP6. Network connections, again, the compute node has a GIGI to the rack lead, but just for that rack. VLAN GBE. Got another VLAN, a virtual network, to the CMC and BMCs. Has InfiniBand to the whole cluster, and restricted communications between compute and system admin. Going to have to SSH through the lead node to get to the compute, or vice versa. Now the compute node will boot and mount shared read-only slash from the rack lead controller. And also the compute node is going to be running PBS software, for example, for batch. Service nodes, the first type that we have that we're using here is for logging in and submitting work. It's one or more per cluster, depending upon how many users and what their workload is like. We do want to be able to configure it and customize it. Running SLUS 10 SP3, SLUS 11, or RHEL 5.4. And then ProPack 6 SP6. The service nodes do have InfiniBand to the entire cluster. They also have GIGI to the rack lead controllers and other service nodes, and another GIGI to the house, to the public network. So the service node users log into this node to compile and monitor the MPI applications. And I got a couple for you to play with. Imaged by the system admin controller. In our case, we are going to run PBS or Torque on it. And we're also going to be using it as a gateway, as a route from the cluster to the public network. There's probably a storage node. Again, these compute nodes do not have disk right now. There is an option to add disks with the latest 8400 generation, but that's for scratch, not for root. Storage node, you're going to have one or more per system. Now it's sharing IP over IB, so it's connected into the cluster. All compute nodes get to the storage node through InfiniBand. And this list might be a little old, but the original was called 4050, which was a 450 with an IS 4000. Nexus 2000, Nexus 9000. Again, the storage node has connections to the InfiniBand. We have an IB0 and an IB1. Normally we try to use IB0 for your MPI traffic and IB1 for your storage. And the storage node does have an ETA0 on the internal VLAN head network, and it has a BMC or an L1 connected into the CMC. Now these storage nodes, you got to configure them whether you want them managed or not. If they're managed, when I power cycle the cluster, it may be power cycling the storage node, which you may want not rebooted because it's needing to be available across other clusters, for example. So there are times that you do not want to reboot the storage node when you're rebooting the cluster. Storage node has an InfiniBand to the IB1 and ETA0 VLAN head for imaging. So the compute nodes are plugged into what's called an IRU, individual rack unit. This is an SGI enclosure for the blades to fit into. Provides power, cooling, system control, and connection to the InfiniBand cluster. And InfiniBand interconnect is in the back panel of the IRU, making it much more stable, reliable, because you don't have cables hanging around. But then when you connect multiple IRUs together, you have to use external InfiniBand cables. So the IRU has 16 single-width blades in it. If we're sticking disks on them, that may take more than a blade slot. There are 2 or 4 InfiniBand switch blades to create your interconnect topology for InfiniBand. 8 power supplies with a spare capability. there is one CMC in each IRU. That's how I get to the individual blades. We have a rear backplane that's connecting the blades together, so both Ethernet and InfiniBand are in the backplane, a fan control board, and a real-time clock. Then we have air moving and also a liquid chiller in the rack door. We're going to have up to 4 IRUs in your 24-inch rack or 2 IRUs that are rotated on their side for a 19-inch rack. So 1-13, showing an IRU. So on the outer side, we have our 8 power supplies. The next in, we have 4 IB switches, 2 on the left, 2 on the right. The older original ICEs may only have 1, depending upon what you've ordered. So there are 4 switch blades in there. This is how we get to a non-blocking interconnect. Down in the lower left is the chassis managed controller, the CMC, and the Ethernet connections for VLAN head, and a couple other networks in there. Also then we see our blades. So there's 16 blade slots. Next slide will actually number them. And off the CMC there is a little LCD display to give the system geography, what rack and location it is. And if you're paying attention, right where this arrow is, this chassis management display, there's a DB9 connector for serial connection. So you can get into that CMC and look at it through the serial port. .114 then is just showing the power supply numbering scheme and our blades. So blade 0 starts in the lower left corner, goes up, and then blade 15, 8 to 15 in the second side. And also port numbers for the InfiniBand. That's a little strange to some people, but they've flipped the blade, so here's 15 here, and then down here is the other 15. Then the CMC down in the lower left. So the CMC, there's 1 in each RU located below compute blade 0. It connects to the compute nodes via my IPMI tool. It monitors the power and cooling, Ethernet ports. It has a field upgradable firmware image that can be flashed from the SAC. And you communicate to the CMC via SSH, or coming in through the serial port, or by using an IPMI tool. Now, in the CMC, there's a file InfiniBand module _ID. That's what determines which IRU in the rack that is. So I might have a rack with 4 IRUs. The bottom one I set to 0, the next one up is set to 1, then 2, and then 3 to be able to get my full rack. I don't know if you're able to see my whiteboard. CMC. So we have the Ethernet switch for VLAN head and VLAN BMC to connect to them.
Is we seeing anything appear on the whiteboard yet? Okay, now I see something.
So after each line, once I hit enter, then it comes through.
Okay, thank you.
The next thing that it has is the power temp fan for the blades in the IRU. It also has the ID firmware and controls the IB switches. Depending upon what your topology is, you need different firmware flashed in there. It's also its own OS, which is BusyBox, so you can log into the thing. And finally, it has the BMC connections to the blades. So it provides multiple purposes. Again, when I get to a demo, I'll log into one. We okay?
Yes.
Now, if you look down to the bottom, these Ethernet ports are all labeled, and then there's an up and a down link, and then this over on the right displays what's connected to the LCD. So we have local, we have LL, RL, and then something called L58 and R58, and then up and down. So the next slide, though it might be hard for you to see, is in the workbook and stuff, in the lab manual, in the admin guide. 116 is showing how these get connected. So we have the up and down, which is basically creating a ring network for the CMCs and the IRUs that are in the rack. Then we have a link that's going left to right across any lead nodes, connecting the racks together. It's hard to see here, but there's also a green line. Now there's something here, this L58, R58 is for synchronized clock across the cluster. The purpose of that L58, R58 is to make sure that clock interrupts are synchronized and occurring at the same time on all nodes within the cluster. We get 250 clock interrupts per second. This clock interrupt is for preemptive time slicing to give the CPU scheduler time to decide who gets to run next based upon priority or entitlement. So this green L58, R58 is just to synchronize the kernels. You do have to run a specialized kernel that has a kernel module to be able to synchronize. We really don't have any performance numbers that prove any advantage to it right now. We do still support it because it's listed as a feature. One of the things it's trying to do is reduce barrier synchronization problems and basically treat the threads like they are gang scheduled and all connected and deconnected together across the cluster. Any questions on this right now?
Yes, sir.
Again, we're not really worried about how it's cabled right now, but understand how it's put together. The compute node. We have newer compute nodes right now. This one was for the 1 or 2 socket Xeon processors, giving us up to 8 cores or 16 virtual cores. Using a Tylerberg 336DIO chip. The Tylerberg was what gives us InfiniBand out. There were 12 DIMM DDR slots enabling up to 96 GB of memory. And by the way, now with the Nehalem Intel chip, Nehalem are NUMA. Each socket now has its own memory. And there are also 2 integrated InfiniBand ports. Again, we've now gone to a quad data rate instead of a double data rate. And these InfiniBand ports are directly output from that Tylersburg chipset. There is no PCI bridge, there's no PCI card. It's native InfiniBand. So 118, we okay? Is this matching your workbook still?
What is the workbook? Repeat, please.
Page 118, are we still, do you see the same as what's on the screen?
Yes.
Just making sure as to what you've got for hard copy. But this is showing the newer Nehalem. And Intel now has what they call the Quick Path Interconnect. That's almost like their version of NumaLink. So each of these Intel sockets, there is a interconnect ring between them. The Intel chip can actually get stuff off the other Intel's memory or off the other Intel's caches even. And off of each socket is memory. We see some green memory there as well. That feeds into the Tylersburg chipset, and off the Tylersburg, we can go PCI out, and then there's a chip to do the DDR IB. Also, coming off the Tylersburg chip, we can go down to get the SATA, things like that, which are not being used, or the BMC. So there are a lot of ports off this chipset that aren't being used.
So this isn't the diagram on 118 in our guide.
In the training workbook?
Right.
So you've got something older still?
Yeah, I've got the old Xeon.
Okay.
Great.
That's what I was trying to just find out before.
Yeah.
So anyway, BMC, every node, every host has a BMC unless it's a IE64 storage node. So the BMC is connected together through the chassis management controller. All BMCs are on that Ethernet. They have their own private VLAN on the same wire as VLAN had. And this is used to connect into the CPU nodes to get bus information, temperature, things of that sort. The BMC is used with something called a serial over LAN connection. So right now it depends upon your system, but we may have one physical RJ45 Ethernet jack plugged in, but there are 2 MACs and 2 ports on that single physical connection. And one of them is for the BMC. And that's how we get to serial consoles. We don't necessarily have a separate serial console port anymore. There are some of the XE systems that do have 2 ports, one for SSH and one for the BMZ, but not within ICE. You configure each compute blade BMC as a DHCP client. So when that blade comes up, it's going to go to the rack lead controller to PXE boot. And you use the IPMI tool command to connect to the admin node from the public network, but then you use the console command to connect to the BMCs within the cluster. Console is a layer on top of IPMI tool. So admin, lead, and service nodes are Supermicro Dexter, Super Server. We might have newer rev levels now for the motherboard. This is used for the admin controller, the rack lead controller, and the login and service nodes. So it doesn't really matter to me, but 1 or 2 sockets that are populated, quad or dual core. I don't know that we're actually shipping 6-core here. Normally we want the high density CPUs on the compute nodes, not the login node. 32 gig of memory, fully buffered DIMMs, couple of I/O slots, 2 gig controllers, and we can intermix and have both SATA and SAS drives in there. Got redundant power supplies and a BMC interface. So 121 is showing what the front and back look like. Showing me my 4 disk drives, some system LEDs. The user guide, the ICE user guide will describe the hardware. Off the back are redundant power supplies, mouse and keyboard. Some of these sites that have, say, 100 racks are going to have a little keyboard and a mouse and a monitor that can move up and down the racks and connect to these should they need specialized troubleshooting. COM port isn't really being used. BIOS is redirecting it to the serial over LAN, the VGA port if you need it, and then we got 2 Ethernet ports, ETH0 and ETH1.
Dave?
Yeah.
Does the system reset button do an NMI, or is it just a recycle of power?
I can't answer that directly. Don't think that there's an NMI off of it.
Hey.
Generally, when we have a hung system, we're connecting with the console command and then using sysrq keystrokes to be able to get a trace back and get a dump. So I don't think that term NMI is really being used within this type of architectural system, being it's an OEM type of system.
Okay.
So when I have a hung one, I come in through the BMC. And with I'll show you serial console strokes to be able to get tracebacks and dumps. Next slide, 122, is just trying to show how the 4 IRUs might get connected. This isn't in other manuals like the admin guide where it might be easier to read. So we've got an IRU 0, 1, 2, 3. The CMCs are connected. And then the InfiniBand ports over on the left and the right. How these are cabled will depend on the type of topology that you're building. And the Chippewa Falls Dick Brunel manuals tell you how to cable for hypercube, enhanced hypercube, fat tree, that sort of thing. Basically, hypercube is the simplest to attain, simplest to cable. A dual plane fat tree, basically you have more ports available and less router hops to build a bigger system. So we generally are starting off with hypercube, then going to a fat plane, and like I said, on UV, we've now got torus 2D type of topology. You do need to know what type of topology, how you was cabled. I don't know if any software command is going to tell me whether I'm hypercube, enhanced, or fat tree. That's going to have to be the administrators or system support engineers that cable the device. And they do require different firmware on the CMCs depending upon your type of topology. But I don't know of any command to tell me that I'm in enhanced hypercube. Page 123 is trying to show naming conventions. So each rack has its own rack number. We basically start at rack 1. Rack 0 was meant for the service nodes and the storage node, the console, that sort of stuff. So our actual compute nodes and cluster really begin with rack 1. So we have an R1 lead, and at the top of the rack is the lead node, which is a Supermicro pizza box. And then we have IRUs 0, 1, 2, and 3 from the bottom up. And there was that system ID that I talked about to specify which IRU there is. So as I add IRUs, I log into the CMC. And let me go back here for a second. ITSYSconfig module ID 0, 1, 2, 3 to describe which IRU it is in the rack. So we should be back at the host name conventions. So in here I've got an example, this particular blades. This is blade 0 within the rack. So 0 through 7, 8 through 15. So this very first blade is R1, I0, N0. I'm just going to randomly pick a blade here. So this one would be R2, I2. Let's see, 1, 2, 3. Looks like C5 or node 5. So it'd be R1, R2, I2, N5 for that particular node. You do have the ability of putting on a locate light to be able to turn on a light to find that particular blade that you want. The CMCs also have their own host names, so I0C, I1C, I2C, and I3C will get into the CMCs here. Almost done. We'll take a break here a few minutes. So we have following VLANs, virtual networks. They may be the same physical wire, but we're isolating traffic between them. So there's a VLAN 1588. That's for the synchronous kernel, so that all clock interrupts occur at the same time across the cluster. VLAN head is my my leader local, leader left, and leader right connections. Carries traffic from the admin to all the RLCs. There's also VLAN BMC, which is on that same subnet to connect all the BMCs together. And then off of each rack lead controller is a GBE network, and that's what all of our NFS route traffic, for example, is coming from. So the next slide, 125. VLAN head for the SSH is a 172.23. The BMC is a 172.24. Then a 172.25 for the synchronous clocks. InfiniBand IB0 is 10.148, and IB1, the second fabric, is 10.149. And then within each rack, we have a GBE and a BMC. These all have a 192, 168, 159 type of naming convention. So 126 is just showing a simple fat tree, 64 nodes or a rack, and how the IRUs are connected. 127 showing a hypercube with 128 nodes or 2 racks connected. Just a listing of the storage nodes. So there's the Nexus 2000, which is a 240, in other words, is x86. Got 12 SAS or SATAs in it, up to 144 drives. Nexus 7000, 16 SAS SATA drives in a tray, up to 224. And this one is an Itanium-based system. And then the 9000, so it's got a 4700 Itanium with 12 SAS, up to 480 drives. So we're almost done. Take a break here. Tempo is based upon Oscar, the open source cluster application resources. Provides centralized software, system provisioning, monitoring, and cluster-specific management. It's a hierarchical design, so we've got admin nodes, lead nodes, login service nodes, and compute nodes. So this management software is giving me hardware monitoring, temperature sensors, stuff like that, power on and off reset. We're using the Open Fabric, and lately the Open Fabric stuff is in SLES. We don't have to bundle it in ProPack anymore. And we also have the OpenSM software to manage the subnet, to do a router, to be able to control how the switches are connecting the different subnets or different network spokes. We have Management Console. There are scripts to do BIOS updates and changes. Compute nodes are easy. The pizza boxes are not. Those you generally have to move from pizza box to pizza box with the USB stick to boot it on DOS. We also have software loading and provisioning, building of images. We have a C3 set of commands like cexec. We're monitoring. We got Ganglia, PCP, and ESP. Closest thing out in Linux for ESP is something called Nagios, N-A-G-I-O-S. And Tempo is using a MySQL database to keep track of host names, IP addresses, MAC addresses, things of that sort. So, this is the heart of what you're going to be doing this week. You're going to get sick of this stuff. cPower, to be able to power up the cluster, power down the cluster, check status. Console command runs IPMyTool, SSHs to the lead node, and connects you to a console. Configure cluster builds up some of the basic configuration attributes like DNS, NTP, and stuff. But the one you're going to get sick of is Discover. Discover is what images the rack lead controller in the service. Tomorrow you're also going to use cInstallman to build your own image, add your own RPMs, that sort of thing. cImage then to create and push the images to the rack lead controller, and cAdmin to change attributes. Tempo really has what's called, or was originally called, the SGI Cluster Manager underneath it. We had Oscar with System Imager, Ganglia console. We had ProPack Foundation with IB drivers and PCP Open, and ProPack Media with ESP and PCP-SGI, and some SLES. When they built the images, they wanted to make them as small as possible. So there are a lot of packages that we might have seen installed that are no longer installed. Kind of listing the releases, so we've just had Tempo 2.0 come out. It is running on George. I intend to leave it running on George if anybody wants to look in and compare. Okay. And note, I do correctly have SLUS 11 support showing in this slide. Once the cluster is built, there's an inventory verification tool. Tempo info gather is what the call center will use. DB dump to dump the database like hostname, MAC address, IP address. And also the SGI release files in ITSI. So in ICE, we have a different one for each type of node, each type of image. It will say whether it's admin, service lead, or compute node. Console-X to show what consoles we have, and ESP, Embedded Support Partner. So, 137. I've assigned each of you a cluster now. Again, I had Megan as George 1, Kevin as George 2, and Connie as George 3. That name is the login node, which may not be upper imaged right now. I'm going to go back to the whiteboard here for a minute. So each of these systems has a George-admin, a George-BMC, and then a George. So George-admin is SSH to the SAC. George-BMC is IPMI tool to the SAC. And then George is different host. And actually, these are all on the .sgi.com subnet. So SGI DNS does know how to find these things. However, if you're outside the firewall or on a hardware VPN, it won't know where to find these. You need to deal with the firewall. So I've given you a cluster and the public IPs, 2 to the admin node, 1 for SSH, 1 for IPMI tool, and then a third IP for a third host, your login node. Another thing that you need to worry about here are power strips. In order for discovery right now, we have to power cycle, and since we're not there locally, we're going to have somebody else do it, or do it through the web. So our admin, lead, and service nodes are actually on network switches. Hang on here. Hang on a second. So I'm hoping you're able to see me jump to Explorer here.
Yes?
And in your workbook, you will be given some IP addresses. I'm just going to put them in, 192.168.182.80. And APC. password to APC. And again, this will be in the workbook. Oops. There we are. So I was only hearing Megan. I hope Kevin and Connie are here. I'm just going to click on one of these.
I can't see anything, Dave. My screen just went nowhere.
As soon as I finish with the slides?
Yeah.
Okay. There will be a screenshot that'll come up. How about you, Kevin?
Okay.
I got it. Thanks.
So this is a web interface to a network power strip that the pizza boxes are plugged into to drop power. I'll come back to this after break, but basically we discover by when it powers up, the BMC does a DHCP, and that's how we identify them. So I have the ability here. This is on George and George 1. So I wanted to drop George. I'm just going to take these two and drop power on them. So I've got off immediate selected and then an arrow for the two. That gives me a chance to apply, and now they're marked as off. So, Megan, your power strip is on 192.48.182.80. It is in the workbook. Connie and Kevin, your power strip is on 81, 192.48.182.81. Only one person can have that thing at a time. So Connie and Kevin, you may need to email or email each other if you happen to leave it open. So I'm going to log out, and now somebody else can get into it. But only one person can be in the power strip at a time. So you've gotten to the BMC, you've gotten the serial console. During break, see if you can get to the power strip for your cluster. Now let's take a 15-minute break and come back about 5 to the hour. That sound okay?
Sounds fine.
Okay.
So we'll see you in about 15 minutes.
David? Megan here. I am trying to access the APC power strip at .80 via Mozilla Firefox, and it does not seem happy with the user ID password combination I am supplying. David?
Yes?
Megan Largo here. I'm trying to access the APC power strip on .80, and it does not seem happy with the username and password I am supplying.
APC should be the password. I mean, APC just once. So you log in as APC, password is APC.
Aha, thank you. I had an error.
We'll restart about 3 minutes.
Okay.
Dave, I'm sorry, I missed the logins for the power strip.
Okay. This is Connie.
Yep.
And you were George 3. And it will be in the lab. I'm just trying to help you as much as possible live too. Let me page A19 in the lab manual also has it.
Okay.
So Connie, you were George 3, which was 192.48.182.81.
Yeah, I'm there, but I was looking for the login. I have a username.
When you hit that, it should come up with the login and password prompt.
Yep.
So the user was APC,
That's
and password was APC.
Okay, thank you.
Kevin, are you back yet? That's the hard part about this. I could be talking and no one's out there. Or worse, I talk myself to sleep. I'm already talking you all to sleep. So I want to try to focus on the labs. That's where the real learning opportunity is. So I'm going to go through 2 modules real quickly. and then we're going to go to lab. And once I call the day, there will be no more WebEx stuff, but support you through email or phone if you need. Kevin, are you back yet? Well, I'm going to go on. So everybody should be able to see startup. Again, I am recording these sessions, and hopefully end of day before tomorrow, Darren can email where to find them, but you do have to download a special viewer. Kevin, you back yet? Well, we're going to go on. So the next module, we got to manage your time. My goal is to have a cluster built by the end of the day. So there is a lab for this, but I skip over the lab. I want to get straight to installation. If you get done and have time, you can come back to this. So page 2-2 of the manual, we want to be able to set up IPMI to control BMC. Use IPMI tool to get to the BMC for power, things of that sort. Also IPMI tool to get to the system console. You've already used IPMI tool on DMZ-server to get to the console. There's also a Java-enabled web browser. So if you point your browser to George 1-BMC or George 3-BMC, you'll be able to get to the web interface for it. Also cover some basic BIOS settings. This is an x86 cluster, and it boots with grub. You do need to worry about and know what menu.lst looks like. That's an LST. Power the system up and down with cpower and use the console command. Now basically, I'm going to have you work in these areas in context as you do the installation and troubleshooting during the week. So IPMI, Intelligent Platform Management Interface, comes from Intel. It's similar to our L1 type of interface. It is a maintenance port into the system. Access and control hardware status, get to CPU information, power information, memory, drive faults, fan, temperature, voltages, things of that sort. In fact, in the ICE cluster, our ganglia is tied into things to catch temperatures and fan problems, and then tell ESP to set off an alarm. So 2-4 is just showing some different syntax examples. You've already used IPMI tool LAN+. And then if there were an Intel motherboard, there's a -O Intel Plus, but these are all super micro motherboards, so that's not required. Also -U-P for admin. Now if you're on an XE cluster again, it probably is lowercase admin. But the ICE cluster is using uppercase admin. There's no feature yet to change that password, so it should be watched and protected. And then -A host name. And again, -BMC, those Georges -BMC are in SGI's DNS. And then SOL for serial over LAN activate. Now if it says it's already busy, then you can steal it. So sometimes I get kicked out because of a timeout or something on my subnet. Try to activate again, and it says already activated, so I have to deactivate it. I can also do a power cycle, but again, if I'm down, it will power up and then back down. I can do a power down and a power up. And again, some of the storage nodes are Intel motherboards, not BMC, so then you need an Intel Plus. But they have changed the login and password on these Intel boxes to uppercase admin, whereas on an XE they might have been lowercase still. And there is a shell capability too. I'll demonstrate that. But you can do an IPMI2 shell and then do commands from there. Sometimes it's very helpful to get command line syntax if you can't figure out the syntax of something. Now this is only needed to get to the admin console. Once you're in, you're basically using console command. Now the BMC has an in-band and an out-of-band. So in-band, I'm logged into the system and talking to my own BMC. Maybe the system just came from manufacturing and the BMC is configured for manufacturing subnet. The operating system has to be up and running to be doing in-band management. We want IPMI tool 1.8.9 at least. And here's what you may have to do. Check config IPMI on and then start IPMI. And then you can do an IPMI tool. There's no -H, there's no -I, just user, password, and then command. So here I'm doing sol info to tell me about my serial line. 2-6 then shows me how I would change my BMC address. Prefer that you not try this on our systems. We might be able to arrange it, but I may need somebody to have a physical console to undo something if you break it. So IPMI tool LAN print 1 will print the current settings. LAN set 1, and then IP address and net mask. Now the IP address and net mask on our subnet are different than these. These are just examples. All but the admin node, all other BMCs in the cluster are DHCP boot. That's the only way that they get a kernel PXE booted. So if that were the case, if somebody accidentally changed to BMC on the service node, for example, then it'd be a LAN set 1 key source DHCP. Kevin, are you in?
I'm in.
We started without you.
I'm sorry, I had some issues.
So we're on page 2-6, just finishing up.
Gotcha.
2-7 is just showing you a LAN print 1. And here I can see I've got a static IP address. Got a subnet, and I've got a MAC address. Now in your case, you're going to, in the workbook, be given for your host what your IP address and subnet mask is. And we do have ours is for subnet mask. Uh, 255.255.192. Nothing else of interest to me on that LAN print 1, but being able to set your IP address, there's a router, a gateway visible too. For sol info, the key thing here is our baud rate. So it's a little bit slower. Compute nodes are at 114, but the admin node, we're running at a 38 kbit per second. You shouldn't have to do anything in here, but occasionally students or somebody has made changes here. So once we've got that everything connected, by the way, when I connect with IPMI tool, and I generally do just a power status first to see if I've actually connected to a BMC. If not, I may have timeout or a wrong IP address or something like that. 2-9 is showing the web interface to the BMC. You can do power cycles and stuff. And you can also, you need Java enabled in your browser, but you can get a screenshot of your remote machine just like you're on the VGA console. Now a little word of warning here. ICE BIOS is set to put all of our output, serial output to COM-B, which is TTY-S1, not TTY-S0. When you're booting the system, if you do a shift backspace or control backspace while you're in IPMI tool, you can drop into BIOS. Again, the one problem we have on our subnet is we seem to get some timeouts, possibly due to the subnet mask. And people tend to get frustrated because they can't grab the console and get a control backspace before it's past that and is already booting. I'll demonstrate that. If I'm on the physical VGA console or the web interface, the delete command will allow me to enter BIOS. And an F12 will invoke a network boot. That's what I did last night on 2 of the 3 machines. I'm going to do the other one today. So this is a Phoenix BIOS, and once you're in on page 211 with the shift backspace or the delete key, then you've got to use left, right. One thing I will tell you, if you're getting into the BIOS and in particular into the LSI mirroring PROM driver software, you really need to be on a physical console. There are keystrokes that do not make it through to control to get into some of the mirroring options that the LSI controller has. So at this point, you can generally handle BIOS, but there are things you cannot do through IPMI tool to the LSI PROM settings. If you're trying to break a mirror and stuff like that, you generally want to be physically attached. And if you look at the top, you can right arrow over to boot and control your boot order. Normal boot order for the admin node is CD first. But since I don't have, 2 things here. A CD into the drive, if it boots, it has traditionally overwritten the drive. Unlike a normal SLES DVD that gives you a prompt to say, boot off a disk or do an installation. The second thing that the installed disk for Tempo does is eject at the end of the installation. And I don't have anybody to push the drive back in. So our systems are doing a Pixie boot instead of a DVD boot for those 2 reasons. And I have to turn on and off the DHCP server on DMZ dash server so that later in the week, if you reboot the admin node, you don't pick up a boot again. 212 just shows our BIOS settings. So normally boot off a DVD and then HDD, but I've changed that to do a Pixie boot. Reboot on power loss, static IP, 38 KB. Login node, same sort of thing. Now the login node, we've got 2 gigabit Ethernets, one to the house and one to the cluster. We got to make sure that 400 here is to the cluster and 401 is to the public house network connection. No resume, it's a DHCP network, 38K baud. The rack lead controllers are set the same way, 38K baud. Again, except for the admin node, the first gig E is VLAN head. On the compute nodes, they're going to do a Pixie boot from the first gig E, and they have a baud rate of 115.2. Again, you get the compute nodes with a command called console. 213 is just showing what a grub menu looks like. The worst thing you want is to be stuck in grub and not know the syntax of where your roots are and stuff like that. So it's always a good idea to have a backup of your menu.lst as well. Key command cpower. That does everything but the admin node or unmanaged storage nodes. So cpower has an option saying no leader, no service. It can do it to a node, an IRU, a rack, or the whole system. Page 215, we can get status, power up or on, power down or off, reset, cycle. There is a boot up target unless already booted. If I have 50,000 nodes out there and a couple did not come up after the first boot, I would do a -- boot to pick up the rest. Usually in a super large system, it could have been contention on the network or something that stalled out. There's also reboot, says reboot even if it's already booted. And then shut down the system. It brings it to single user mode but does not power it off. And at shutdown mode, you still have disks running. They have not been synced or anything like that. Halt will bring the system all the way down to a powered down state. But again, the BMCs are, as long as the plug is plugged in, BMCs are always running. BMCs are vampire devices. And then C-Power -- identify can turn a blue light on any node out there. So I just did an example here, C-Power -- status R1 asterisk. Now when you get in the admin guide, they may put quotes around the asterisk to turn off file globbing. Sometimes they'll be there, sometimes the quotes won't be there. And a C-Power -- system does status on the entire system. Here I had a C-Power -- system that had an error. IPMI tool was timing out. You have to be careful of that. And then 218 is doing a shutdown. Now notice I used a wildcard with an R1, so it's warning me that the lead node is also going to get shut down by it. Also, once you've got the admin node installed and another node installed, console command is how you get to it. Console -X will show you what consoles you can connect to, and then console node name will basically run SSH IPMI tool sol activate across the network. Now when you're in the console command, Control EC * for help, but Control EC dot to exit the console, or Control ECF to steal the console, or once I connect, by the way, all console output is being logged to the admin or lead nodes and are viewable. But when you connect up with console command, Control ECP can play back the prior output. For example, you connect and you see the end of an oops, you see the end of a panic, and you want to see the prior stuff. That is available both in a log and with the playback. There is rescue mode capability. Basically, again, you're coming up with a Brian only EL kernel and a BusyBox operating system. So there are some additional references on 221. Probably the best is IPMI tool help and C-Power -H. So I'm not going to worry about this right now, but check your syntax. There are some labs to play with, but I don't want to spend time on them right now. I want you to get your system installed by the end of the day. So you get power status, LAN settings, sol settings, and get the console, which you've already done. And then you can try during boot to bring up the BIOS with a shift backspace, and then check on any BIOS settings you want. Any questions on that module right now?
No, not at the moment.
A lot of people have already worked with IPMI tool in the XC environment. Console is just a layer on top of it. C-Power is a layer on top of it. So here's the big one. Installation. This is what I want you to do when I'm done with lab. I'll give you some page assignments here. We want to install the admin controller. I've already started that on 2 of the 3, and I'm going to demo the 3rd one. They're ready, the 2 that are installed are ready for a reboot, and then they're going to come back into a first boot situation, and you do your normal YAST first boot fillings like network settings. Then you're going to run configure cluster. A configure cluster is going to copy SLES and ProPack into a repository in the SAC. That repository is in TFTP boot. And then on DMZ-server, so we're basically copying and building stuff from this install directory into the TFTP boot directory. So your admin node has a repository with repository control using yummy. You're also going to specify the cluster DNS domain name. We're just using the same name as the login node, George 1, George 2, George 3. Set up network time protocol, and then build the database for these lead service compute nodes. Then you're going to go to that power strip and drop power on your lead and your service nodes. And then you're going to use the discover command, and the discover will tell you when to power it up by plugging it in. That's when you use the power strip to apply power to the BMC. Compute nodes are automatically discovered. So 3-3, install the admin node. That's what's already been done. On reboot, fill in the first boot. That's where you are. Run configure cluster to build the RPM repository, define your domain. Building your database actually builds images too. That will take about 45 minutes to build these images. It takes a little bit over an hour to run configure cluster from scratch. You're also going to define your house DNS. So then here's what I said. You unplug. We're using the network power strips to unplug our service and leads. Run discover --rack1 and then power on the lead controller, one at a time. This will result in the BMC powering on, which will do a DHCP request that identifies the node. After the rack, you're going to do the service with the --service 0. Then you plug in your login node with the web address, the web interface. Now, I kind of expect some problems here. In order to decide what disk to target, Tempo has labels in the file systems. It is going to look for an SGI root, SGI swap, SGI boot. If they're there, then it just takes off and uses those to overwrite whatever's there. If it doesn't find those labels, then it's going to look for no partition table. If it doesn't find anything that is imageable, then what you got to do is you're going to be at a BusyBox prompt with an error, and then you use parted make label MS-DOS and then DD to clobber at the beginning of the drive to make it basically no partition. Then rediscover, and it will use that disk to image. So it will fail if there's no or multiple SGI roots and no blank disk. Now, if you wanted to monkey around with these labels, E2 label and XFS admin can change labels. And I have had problems when I'm moving between Scali and Temple because LVM labels can be a problem. They're a little bit deeper than sometimes the 8K or something. The 16K was important. There are times where I've gone to 32K deep to clobber the drive. So 3.5 is kind of looking at we now support what's called a multi-slot or multi-boot, depending upon how big your root disk drive is. In my advanced class, I basically go 4 slots or 4 boot disks, but then they get pretty small. So we only have one swap partition, SGI swap, and then we have SGI data, and then we have an extended. And in the extended, we have our SGI boot, SGI root, and then the next slot, SGI boot 2, SGI root 2. So when you're done parted, we'll show you how that root device has actually been put together. Basically, if there's a problem, you're going to follow the BusyBox, and BusyBox will say, I don't know what drive to target. So then you're going to figure out which drive you want to image and clobber the partition table. Now, I've already set up the install Pixie boot options on DMZ-server. So these things are something that I've hard-coded when the system was installed. So installing, repartition the admin node to allow for a specified number of slots. So I could have 4 slots or 4 roots there. 2 is the default. So in the week 2, we do a SLES 10, a SLES 11, a Red Hat, and a clone. That gives us 4 slots being used. We can clone any slot to another slot position. And then there's an install slot option to say which slot do I want to install on. And a destructive allows me to actually clobber the drive because I know what I'm doing and I don't care about anything on the drive. So 3-7 is where everybody is right now. Well, actually, George 3 is not. Takes about a half an hour to install the admin node. Most of it is the MakeFS and the loads. Now again, I'm having problems in my subnet where IPMI tool is timing out, and it gets a little frustrated when you can't grab the console before it's booted. And trying to grab the console, getting an F12 in quickly has been problematic, and I've got a PV open on it, but it's not being fixed. That's why I basically started it for you. So you're going to log in and do a reboot. I'll give you lab manual steps coming up here. So 3.8, basically that's where you're starting in class. After the reboot, you're going to come up on a welcome screen. Then you're going to fill in your host name and domain name. Be careful. A lot of people make mistakes here. They don't backspace over what was there before. They get a wrong domain name. This can affect things like ESP as well. Service location provider. There are a lot of things that use that host name. So make sure you get it right the first time. Then the next screen is for your network interface configuration. So you're going to tab to change, which was down a button down here, hit enter, and then you got these options here for network interfaces. The network interface going to the house is ETH0 on the admin node. Service nodes is ETH1. So I select ETH0, the first entry, tab to edit and hit enter, and then fill in my IP address. So we're going to be in the 192.48.182 domain, and again the net mask I gave you already. And we want static. Then for DNS, again domain name SGI.com, and then the domain name server. And again, these numbers will be in the lab. So now I'm back to my network address setup. I've now tabbed to routing, and then filled in my router gateway. That's also the NTP server. Then I'm doing my time, tab to central, or tab to time zone. We are in the central time zone here. And then put in your password. I'd like you to use SGI for root password. Authentication method. Generally, admin nodes don't have a lot of people on them. They're usually local. But we're just going to use local ISI password for user accounts. And we generally do not add a guest account here, so just do next. Don't care about hardware, skip to do next. And your installation is complete. Now at this point, you'll see that get out of YAST and do the rest of the stuff. You will see some errors, ignore them. Generally what I do is a reboot right away. Before I go on, I generally make sure that I can boot the system again. So at this point, your install node is built and complete. Any questions? Are we okay?
I think I'm okay so far.
Again, doing it will make it sink in. So there are some issues here on getting the serial console. We're installing entirely over serial over LAN. We've got no VGA access. So again, the kernel boot parameters are going to have a TTY S1 in them. And the BIOS is redirecting to COM-B. If I'm on a VGA console directly connected, then I may not be able to get to the SOL. If I try to activate it, it says failure. That's because I'm on the wrong TTY. So there are issues with that. Again, using the VGA console to install. A lot of people get confused. After you've installed with the VGA console, on the reboot, it sends its output to serial 1, not to the console. And you need to use IPMI tool for the second half of an install. So some people see the message kernel rebooting and then sit there for a couple hours not knowing that the output went to COM-B instead of the console they were on. So it is a common problem of waiting for that kernel reboot. And it's rebooting, it's just the output's going somewhere else. So after the admin node has been installed, and I like to reboot right away to make sure that it's working and everything, then we go into configure cluster. In this case, it just says I've got an initial configuration, follow all steps in order, and then here's our configure cluster menu. So the first one is to set up the repository for SLES or Red Hat and ProPack. Secondly, network settings, then network time protocol, and it's this one, infrastructure setup, that can take an hour, as is building images. And then lastly, configure your host DNS. So in this case, I selected Repo Manager, went in and says, one or more ISOs are already in the install DVD, let's add them to the repository. So it'll flash to the console, and here we can see Foundation and Tempo are being added into the repository by a command called crepo. And we have repository control with metadata and checksum information, things like that. So then you hit enter and you're back into configure cluster. Now be prompted to add additional media such as SLES, ProPack. Unfortunately, the Software Development Kit, SDK, is not part of this infrastructure. Talk about that tomorrow. So I say, yes, I'd like to register media with Tempo. Now again, I don't have the ability to shuffle DVDs, so we have a install tree off on DMZ-server. So I tab the custom path, and then I fill in DMZ-server, ISO, and this should all be fine for the name of the ISO. Now it'll take about 5-10 minutes for it then to copy that ISO into TFTP boot. Then you get back successfully registered with crepo, and don't forget to eject the media. Then I want to do register media again, and this time is ProPack. Now you've already registered Foundation, but not ProPack. So again, it's DMZ-server/ISO, ProPack 6 SP6, name of the ISO. Within this cluster, guest and a password of guest would get you into the DMZ server. Finally, that goes rather quicker than SLES, so then it says that's registered. And finally say, would you like to register with Tempo? No, there's nothing more I can register. So I'm back to the beginning menu of install cluster and doing network settings. And configure subnet address, I'm just showing here. Generally, you are not changing this one. And changing means you have to restart your entire, re-image your entire cluster. So this is what it looks like, and this allows the opportunity to change these IP addresses. Maybe you need to have the InfiniBand IP addresses to be something that integrates into the house IP addresses or something. But we're not going to change any of this. So then I went back, got configure cluster domain name, said OK, went in here and then named my domain. This is for this is for DNS, not NIS. And I basically want you to use your cluster name for the domain name within the cluster. Then network time protocol, a warning message, and you're going to want to tab down here and do an add. We want to add an incoming broadcast. And then I selected incoming broadcast. And then this is the IP address of what our DNS, our clock synchronization is from. 192.48.182.65 is our clock server. So after that's been added, then you're going to tab down to finish, hit enter, and then you're off to perform initial admin infrastructure setup. This is the thing that's going to take an hour. It's going to build 3 images. So warrants you 3 OSs. It's putting it at 30 minutes. For me, it's been over 45 minutes. And then once you hit that, you're going to see it going into this. This is where we're actually generating the image. This is the command that may take 15, 20 minutes per image. This is important. While that image is being created, this is what you're going to do tomorrow. Build a custom image with added RPMs such as PBS and then that pitch. You want to watch this file right here for any errors on building that image, like conflicts between packages or package missing, things of that sort. You're also going to specify your own RPM list of what RPMs you want in your image. So an hour later, that comes up, finishes, and then you configure house DNS and stick in 192.168.176.12 as our DNS server. And it says it sets a DNS forwarding. Now, I don't know how much NIS and DNS and NTP background you have. Let's just deal with those as we go along. But there is an ITSI named.conf. So DNS is a daemon named named. And named.conf will have this 192.168.176.12 at the top of the file. Now I'm back to the main menu, and I actually have escaped, and now I've got the actual real main menu, not the initial setup menu. If you looked earlier on page 353, we had an initial cluster setup. Now we're back to a main menu, which we have not seen before. And we've got three new options in here. Configure external DNS masters, configure your InfiniBand, and reset the database. So here's that web browser. So I'm going to point it to the power control strip. You've got to decide whether I want on and off, so select the particular nodes. Make sure you get the right ones, and make sure you log out when you're done so that the other instructor or other student can get to this web power page. So once it's powered down, you then run a discover --rack and the rack number. Some options we can talk about later: delete the rack, delete a service node, external switches, things like that. And then we're actually seeing discover. So here's where we run. After the discover, it says, turn on the power, but do not turn the system on. This means plug it in and back, but don't hit the on switch in front. The on switch in front is going to be automatically turned on by the software. And it is giving me the rack that I'm looking for. So normally then I go off and find the rack that I want discovered, plug in the rack lead controller. That results in the BMC booting, putting out a DHCP request, and now the admin knows which BMC they're trying to discover. Now, it may be slow for all of you, but there is a Tickle GUI to monitor the installation, and this is only for lead and service nodes. Compute nodes are monitored differently. They have no disk. And here we're monitoring the console. So grab the console command and we can watch the system being imaged. So here I have another monitor showing that both nodes have been completed and are in the process of rebooting. Watch your MAC addresses. Make sure you got the right ones. Now, discovering the compute nodes is handled by BladeMonD. People get burned here. You have to have patience and wait. After the lead node is rebooted, it still takes another half hour to actually discover the compute nodes. So this daemon called BladeMonD running on the rack lead controller does automatic compute discovery. It's going to pull images from the rack lead controller. Now, see image, show default, and set default will say, which image do I want as my default? Discover is going to set up, or BladeMonD is going to set up the consoles, ganglia. There is a net R1 lead var log BladeMonD file for diagnostics, and also on the admin node of var log discover-rack. That one's an important one. Too many people think that after the reboot, everything's done, and then they yank the system, and the discover the compute node does not work correctly. They blow it up. So you got to have patience at this point. If I am running multiple routes, then I've got slot capability. So cadmin has the ability to show me my route labels. So here I had 4 slots. I was running Tempo 1.7, and a SLUS 10 SB3, a SLUS 11, and a RHEL 5, and another slot to clone. So here I made a copy of one of my routes and cloned it to the 4th slot. When you're running clone.slot, you got to be careful. If you break out of it, it's going to leave systems in a mess. You may have unmounted file systems and stuff. Did a cadmin show default route, and then show current route. Then I set my default to 1, showed my default, and then I halted and in at 6 to actually go to that new route. Now there's also a database reset. Basically you have to rediscover everything at this point. Sometimes you need to do it because Chippewa Falls has shipped the system with ice.americas.sgi.com. Wouldn't have to do it if subnet addresses aren't changed. But once you go into this, there's no chance of breaking out. Once you do a reset, you're going to have to rebuild images and start all over. So here was the reset menu down at the bottom of the main menu. Warns me that this is going to discover all components from scratch again. And then it clears up the database. And again, you're going to have to perform the initial admin node infrastructure changes again. So I am done with lecture for the day. Page 3-39 is basically what I want you to do for the rest of the day. I'm going to demo here real quickly, but I want to install the admin node and then reboot. Fill in the first boot screens. Then run configure cluster, then discover dash, those should be 2 dash, dash rack, dash dash service. Then once the system has been discovered, inventory the system. Do tempo info gather, run db dump, check your SGI release files, dig into DNS, dig into disk. These 2 are optional. Time-based. And in the admin guide that's on docs.sgi.com is Chapter 2. So you should be able, I've switched over to my desktop now, you should be able to see my desktop. I'm going to go to DMZ-server. Log in as guest. Now I'm going to grab George 3. That has not been done yet. First of all, I'm just going to SSH to George 3-admin. Oops.
I'm still not seeing anything, Dave.
Yeah, I'm not going to be able to help you.
Okay.
Once I go to this live demo stuff, whatever Windows thing, Darren might be able to, but I'm not sure why you're not seeing me. I don't have a solution for you.
Okay.
So there are screenshots and everything. I'm just trying to do a quick demo. So I've SSH to George 3-admin. I've logged into it. I'm going to do a cadmin -- version. And I see that this is a Tempo 2.0 and it's running SLUS 11. I'm going to cat /ITSI /*REL**. And I can see the same thing. It's a 2.0 and a SLUS 11 system here. Now, the labs are written for SLUS 10 SP2. If you want a SLUS 11, I do have a lab procedure for that. But the book has been staying to SLUS 10 right now. I'm just going to do a PS-E and grep for IPMI. Shows that IPMI is installed or running. Check config on. And service IPMI start has been done. So I'm going to do an IPMI tool -u admin -p admin and then shell. Again, I'm talking to myself. So now with the shell command, I can type in help, show all the different commands. Power status, I can see it's on. Again, I can do a LAN print 1 and see my IP address and my net mask. And I mentioned the gateway too. Now I can see the gateway in here. I'm going to do a sole activate. Oops. Since I'm not on the network, I cannot get the serial console. It's not available here. So I'm going to quit out of there, exit out of here. And now my IPMI tool, let's see. So I'm going to do IPMI tool, uadmin, padmin, LAN plus, George 3 BMC, sole activate. And now I've got the console. To get out of this now is a Control D C dot, Control E C dot. It's not liking something here. Oh, that's right. I'm in IPMI tool, not console command. That was my mistake. If I was actually on the console command, it was a Control EC dot. Here it's just a tilde dot. I'm going to do a root login, password SGI. So here's the painful part. Let me back out for a second. You do not have root permission on DMZ server. If you need the DMZ started for some reason, email me. I'm going to start DHCPD. Start. Now, Connie, I realize you can't see my screen. I'm just going to have to talk you through it. Maybe you can SSH into DMZ server. But I'm going to go into TFTP boot, and this is where I'm installing from, and in here I've got my admin install kernel initRDs. I'm going to go into Pixie Linux CFG. So I'm in TFTP boot, pixielinux.cfg. There's a README here. And my Georges all have a C0 beginning to them. That is basically the MAC address converted to hex. And there is a little script in that directory called hex to convert an IP address to hex. So if I ping, let's see, George1-admin, and now run hex on 192.48.182.71. That tells me the C030B647 is going to be the kernel boot parameters for that IP address. I'm going to more on ITSI, DHCPD.conf. And in there then, here's my George1-admin with the fixed address we're going to give when we get that MAC address coming in. So when we see that MAC come in, there will be a few messages in varlog messages. Then we're going to assign it this, and then go off and execute the configuration file.
Okay, that was George 1 admin that you were just highlighting, but you're actually doing the example on George 3?
Sure. Yeah.
Okay.
I just happened to pick what was closest.
No problem.
But yeah, George 3 is the one that I was actually going to do a initial install on, correct. So just looking at one of these. So this thing is actually set up to have different releases of Tempo. I'd like you to use Tempo 1.10. That's what I've installed. I have not 2.0 is working and everything, but I haven't matched the labs to make sure they work on 2.0 yet. So there is a menu that comes up here, and you get by default 1.10 after about 10 minutes, 9 minutes. I'm just going to page down here. So here's my 1.10. Pointing to the kernel that I put together. Basically, I grab the ISO, mount it, and grab the kernel in initRD. There's my console as TTYS1. Then I'm doing a network install off the ISO, the admin install ISO. And I do have to have admin node 1, monitor console yes, destructive 1, and then here's where I said I want 4 partitions. So if you want to know more about that, you can talk to me offline, but that's just setting up the Pixie install server since I don't have somebody there to shuffle DVDs around. I've also got entries in here to load slot 11 to slot 2, rel into slot 3. Those are for the advanced class. And the other instructor did one. Did a Tempo 2.0, but maybe not in this particular host. He only did it in a couple of them. So there is a 11 here that can do a Tempo 2.0. Let's see. Anyway, now that I've got that server started, the DHCP server, and I just showed you how itsy.dhcp.conf and tftp boot pixie linux.cfg files were set up for the installation. That's non-standard. That's just because I don't have a person there to shuffle DVDs around. So I'm going to grab the shell again. Let's see, that's George 2. I wanted George 3. I always like to do a power status first to see that I'm talking to something. I am. I'm going to do a sol activate, hit enter, and I'm on George 3. So I'm going to do an init 6, and this is where I may get the timeout problem, so we're going to just have to watch this. This seems to be unique to my subnet and the netmask that I've got going on. When these systems were in our normal subnet, we were fine. Now again, I do hope that you get some problems and can solve and fix the problems. Part of the class is trying to troubleshoot things. Labels, I expect and hope that you see some label problems. There, I just got a timeout. So what I generally do now, since I've got that timeout, is drop back to the command line and just keep waiting until I actually connect. So I don't sit there waiting too long. Control-C will break it out unless I've connected. If I do connect, Control-C won't take effect. So we'll see how long this takes here. Got to have a little patience at this point. That's why other instructors are doing it just to avoid the impatience. So there, now it says it's got somebody else. So now I'm going to do a deactivate. Now I can activate and hit F12. And I hope I hit it just in time. But that's a real tight timing window there. And a lot of people tend to get the console after it's too late. Also, if you connect and you did get the F12 in, it's sitting there waiting for a Pixie boot choice for 500 seconds. So I'm going to try a 10 here. Nope, let's just wait a minute. it may time out on me again. There we go, timed out on me again. Now I'm going to try again here. And I'm going to hit 10 and hit enter, and off it's going. But I knew that I got the F12 in there quick enough because I saw the Pixie boot stuff. And then when I reconnected, it was dead, seemed to be dead, but I knew that there's a pause point there to say, if you got the Pixie boot in, we're waiting for the choice of what you want to install. But students, the timing and stuff like that doesn't always work. So that's why I was doing it on my own. Okay?
Okay.
Any questions?
Not yet.
So I'm basically done here. Connie, you had George 3, so in about half an hour, you can connect in, Connie, and watch it. So there, I've got the installation of George 3 going. The long part will be the MakeFS. Again, Connie, you can steal the console from me by doing the sol deactivate and then the activate.
Okay.
And let's just see what we got here. So it looks successful. It did not complain about any label problems. So it said we found SGI root, SGI boot, SGI data, and then went off and partitioned things. And now it's on the MakeFS. So that'll take about 15-20 minutes. Kevin, you still there? Guess not. So lab, page A12 to page A23, done before tomorrow.
Okay.
If time, A23 to A27. It's just some inventory stuff to poke around and see what DNS files look like, resolve.conf look like, things like that.
Okay.
So I did not pursue further with this example on Connie's, but basically it'd be configure cluster, discover the lead, discover the service, and then figure out what you've got. Okay? So I'm done for the day. DAW@sgi.com. It's lunchtime for me right now. I'm going to grab lunch and then I'll be back online.
Okay.
And I'm also having I'm having a bad knee thing, so I'm going to be delivering from the office, but then I'm going to go home. Oh, I missed this. Hang on a second. Storage node on ice dropped. Oh. Kevin had to respond to a storage node failing. I just didn't see his email or his chat. Again, I'm generally not watching chat. It's pretty small within my window, so. So anyways, because of a swollen knee type of problem, I'm spending the afternoons from the home office. But if you need to talk to me, I'll give you the phone number when needed. I won't be in the office in the afternoons. But don't use my phone number. I'm never in the office. I'm usually on the road running classes, so email is the way to find me. So anything else, Megan or Connie?
Not at the moment. I'm watching it. It scrolls down here.
So yeah, just feel free to try again, get back to me, do what you want. Tomorrow we're going to configure InfiniBand and then start customizing. It's the customizing that's painful. Being able to set up all the different things. Feel free to look ahead into the labs if you want, feel free to poke around ahead in the labs if you get ahead. Usually people are not ahead. So,
I fear that I am the only person who has 0 SGI C3 experience in this group.
yeah, but this is all just Linux.
Well, I mean, I'm familiar with booting a cluster via TFTP boot. I've done that before, just not in the SGI realm.
Yeah, but we're just Linux. But don't be afraid to ask any questions, Megan.
Okay, thank you.
You know, being newer or whatever, again, to me, it's still basic Linux. Playing around with this, the hard part is understanding the topology and the components and how they're put together into our different clusters. And we do have Platform Manager as a cluster manager for ICE, and there are plans on what was formerly Linux Network Systems ClusterWorks that got renamed ISLE and now renamed SGI Management Console. That will have a layer on top of Tempo. It will not replace Tempo. It will basically be screens running Tempo commands. So there are other pieces that customers may have, Scali Platform Manager product or an ISLE interface on top of Tempo. So let me know anything that you have, email, or if it's a longer conversation, we'll talk on the phone.
Okay.
Anything else?
I'm
Okay.
good for the,
What was that, Connie?
I'm good for the minute.
Okay. Like I say, I don't mind you getting stuck, but don't get stuck for 2 hours or go off and do something else because you got stuck.
Okay. All right, it already got to installation is complete and the root has been safely unmounted.
Good. So you're ready for the reboot and to pick up on page A12.
Okay.
Go ahead and skim through the lab before A12, but I'm just trying to get the accomplishment of having a installed admin node and a discovered lead and service nodes. And don't forget to give time waiting for the compute nodes. Some people will reboot the admin node before the compute nodes have been imaged. Or I should say their roots have been built on the NFS server. So that's a common mistake. I try in my labs to mark where people have common problems to give you some tips.
Okay.
But don't be afraid to come to me. I don't want you to lose attention, and I do want you to think about and get stuck on a problem a little bit, because then you remember better. If it goes too smoothly, it won't the next time.
Okay.
So it's always good to have the problems now. Don't get frustrated if you have problems.
All right. Thank you.
So we'll talk to you later then.